we are on to our second video in this unit, which is sample space. Okay, so what is a sample space? Is the results or all the possible outcomes for an event or an experiment. All the possible outcomes that there are. Okay, so a sample space can be shown as a list, it can be shown as a table, or it can be shown as a tree diagram, and we'll talk about all three of those coming up here. Okay, so here is our first example. We've got Mary, Jim, and Brett who are playing a game that uses two spinners. Okay, the first spinner has two sections. Go ahead and go back. So here is that first spinner. Okay, oops. And then the second spinner has three sections, which are one space, two space, and three space. Okay, so think about playing a board game, and if you had to spin two spinners to move ahead or move back. So you spin this first spinner, you could land on go ahead, you could land on go back. You spin this second spinner, you could land on one space, two spaces, or three spaces. Well, it wants us to find all the possible outcomes that there are for how a player could move. So all the ways that this could turn out for a player. Okay, so we're going to look at a couple of different ways to do that. We're going to start with doing this with a list. Okay, so with our list, first we want to start with the first spinner. Let's start with go ahead. Okay, so we could land on go ahead, and if we land on go ahead on the first spinner, we could land on one space on the second spinner. Okay, we could land on two spaces, or we could land on three spaces. Okay, so there's three different options there. Okay, and then what if, though, we land on go back? Okay, well, if we land on go back on the first spinner, we could land on go back one space, we could land on go back two spaces, or we could land on go back three spaces. So again, three more options there. So if we want all the possible outcomes there are, well, we've got 1, 2, 3, 4, 5, 6 different outcomes that there could be for spinning these two spinners in a game. Okay, I'm not going to go through a table too much because when you see, it looks a lot the same, right? It looks like they've got what we've got on the first spinner and then the second spinner. Go ahead with one space. Go ahead with two space. Go ahead with three spaces. Or we could land on go back with one, go back with two, or go back with three. And so we still end up with 1, 2, 3, 4, 5, 6 different possible outcomes. Okay, and so since a table and a list are so close to each other, in class you'll usually hear me say make a table or a list. I'll give you the option there if you want to set it up as a table or if you want to set it up as a list. Okay, now let's go ahead and look at the tree diagram. Okay, so with the tree diagram, we're going to start with our first spinner, which was we could land on go ahead or go back. Okay, so this go ahead or go back with spinner 1. Okay, all right, and then we want to consider what we would get on the second spinner. So we need to branch off from the choices for this first spinner to the choices for the second spinner. So we've got spinner 1 here. Now we need to branch off for spinner 2. Okay, branch off as in branches of a tree. Okay, and so we could land on go ahead one space, go ahead 2, or go ahead 3. Okay, if we land on go back on the first spinner, we could go back one space, two spaces, or three spaces. Okay, and so this is what a tree diagram looks like, branching out from your different choices. And again, if we count them up, we've got 1, 2, 3, 4, 5, 6 possible outcomes, even if we use a tree diagram. Okay, now some of you may be thinking, okay, we just did probability. How does sample space fit in? Well, if you think about our probability formula, okay, remember with probability we did number of favorable outcomes, so whatever we want to happen, number of favorable outcomes over the number of possible outcomes. Okay, so with sample space, we're given this number here, our number of possible outcomes. So if I asked you what's the probability of getting go ahead 2 spaces? Well, go ahead 2 spaces is one favorable outcome out of now 6 possible outcomes. And so that's kind of how sample spaces relates to probability, if you were wondering, okay? All right, so what I want you to do here is go ahead and pause the video while you work the next 2 examples. All right, so on your next example, you were supposed to make a tree diagram for all the possible outcomes for this recipe with 1 herb and 1 spice, okay? So I am going to start with the herbs, okay, and I'm going to abbreviate some of these. So on my herbs, I've got basil, I've got bay leaves, which I'm just going to use BL, I've got chives, and I've got dill. Okay, so I'm starting with my first event, the herbs, okay, and I'm going to branch off of that for my spices. Okay, so I could have basil with paprika, I could have basil with pepper, or I could have basil with garlic powder. Okay, same thing with my bay leaves. I can have bay leaves with paprika, bay leaves with pepper, or bay leaves with garlic powder. And make my branches for chives with paprika, chives with pepper, or chives with garlic powder. And the same thing with dill with paprika, dill with pepper, and dill with garlic powder. Okay, so there is my tree diagram with all my possible outcomes, and I don't want to forget to answer the question, which is how many different recipes are there? Okay, so if I count up the ends of my tree diagram, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so there are 12 different outcomes or 12 different recipes that can be made here. Okay, again, 12. All right, so now let's check your second problem that you were supposed to do on your own. All right, you've got the theme park that provides its workers with uniforms. They've got these different shirts and short combinations, and I believe you were supposed to make a table or a list. So I'm going to make a list comparing shirts and shorts. Okay, so I can have a green shirt, and I can have that shirt with white, khaki, or gray shorts. Okay, I can have a red shirt with white, with khaki, or with gray shorts. I can have a blue shirt with white, with khaki, or with gray, and I can have a black shirt with white, khaki, or gray. So there is my list of all my possible outcomes. If I count them up, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So again, on this answer, we've got 12 possible uniform combinations for these theme park workers. Okay? All right, so make sure, guys, that you understand the table, listing, and tree diagram as ways to show your sample space. If you're not positive on those, make sure you rewind or slow it down, go at your own pace. And if you are ready, we are going to move on, okay? And with moving on, we are moving on to one more concept, which is called the fundamental counting principle. And this is one more way to show your number of possible outcomes. Well, the fundamental counting principle, it determines your number of possible outcomes by relating the number of outcomes to the number of choices. Okay, so the fundamental counting principle relates the number of outcomes to the number of choices. If you need to pause to get that definition down, then do that. Okay. All right, so let's look at that same theme park uniform problem, okay? And I'll just walk you through how the fundamental counting principle would be used for that problem. Okay, so first thing you want to do is list your different categories. So with the theme park uniform, you had shirts and you had shorts, okay? So there's my 2 categories. The next step that I need to do is set up a multiplication problem using the number of choices you have for each category. So shirts, there were 4 different choices for shirts. You could have had like red, blue, black, or green, okay? And then there were 3 different shorts. So you had shorts in what, khaki, gray, and black. I'm not sure, I couldn't remember. But there were 3 different shorts. And so all you do from here is multiply to get your total possible outcomes. So you're multiplying the number of choices you have for each category. And so 4 shirts times 3 shorts gives you 12 possible uniform combinations, okay? So let's look at that fundamental counting principle in another problem, okay? So Christina conducted a probability experiment by spinning the arrows on 2 spinners below. Use the fundamental counting principle to determine how many possible outcomes there are if she spins each spinner once, okay? So first we've got to list our categories. So our categories here are spinner A and spinner B. Okay. Then we want to list how many choices there are for each category. So you've got 1, 2, 3, 4, 5, 6. So 6 choices on spinner A and 1, 2, 3 choices on spinner B. And all we do is multiply those 6 times 3 to get that there are 18 possible outcomes here. 18 possible outcomes. Easy enough, right? All right, so then since that was so easy, go ahead and pause the video while you work the last example. All right, last example we've got here, guys. You've got Michael walks into his favorite shop and he's got to figure out how many different sandwiches he can make. So again, fundamental counting principle, we want to list our different categories. So in this problem, he's got to choose the bread, he's got to choose the meat, and he's got to choose the cheese. Okay? And if you look at it, he's got 2 different types of bread. He has to choose from 3 different types of meat, and he's got 4 different cheeses. And so all we're going to do is multiply. 2 times 3 is 6. 6 times 4 equals 24 different sandwiches that Michael can make. 24. All right. So that was much quicker, right, than making a tree diagram or table or list. And so you just want to make sure you pay attention. What is the problem asking you? Does it want all the possible outcomes, or does it just ask for how many? If it just asks how many possible outcomes, you can use the fundamental counting principle as a shortcut. All right? All right, guys. Well, make sure you don't finish out tonight without doing your summary. Your summary asks, how can sample spaces be used to determine probability? Okay? So make sure that you answer that in complete sentences, at least 2 complete sentences, and come to class ready to work on sample spaces tomorrow. Bye.